Hello everyone, myself Dr. Ishad Ahmad Khan, working as an associate professor in Department of Mechanical Engineering, Sagar Institute of Research and Technology, Bhopal, the SAGE Group. And today I am here to present type of the pairs, or you can say the type of kinematic pair under the subject theory of machine. So let's discuss type of kinematic pair. So let's first understand what is the kinematic pairs. A joint of two links that permit relative motion is called pair or kinematic pairs. The type of pairs are, first one is according to the nature of relative motion, according to the nature of contact, and according to the nature of mechanical constraint, or we can say mechanical arrangement. So let's discuss in detail one by one. So under the according to the nature of relative motion, we have some pairs that are sliding pair, turning pair, cylindrical pairs, spherical pair, helical pairs. And under the next category, according to the nature of contact, we have lower pairs and higher pairs. And in third category, the nature of mechanical constraint, we have two type of pair, that is closed pair and unclosed pair. So let's discuss in detail with the help of diagrams, understand how these pair possessing their motion and also the degree of freedom. So you can see this is a diagram of prismatic pair. So in the prismatic pair, you can see it's allow only the relative translation between the element 1 and 2. This element 1 can translate just only, it is translate according along this path. You can see that. Okay, and you can also see that this inside prism 1 only can translate, so we can say this pair having only 1 degree of freedom. So let us see the next one. The next pair is turning pair or revalued pair. So you can see the revalued pair, this pair allow only relative rotation between the element, this element 1 and element 2. This is element 1 and element this one. What is the element 2? This one is 2 and this one is 1. Can express by only 1 degree of freedom, and that we can represent by the symbol theta, because there is a rotation. So it having 1 degree of freedom. So we can say only one independent motion is possible between element 1 and 2. That's why its degree of freedom is 1. So let's see the next. Rolling or cylindric pair. So as you can see here, this pair allow the both rotation as well as a translation about the the translation parallel to this axis of the this cylindric pair, and rotation about this axis. So this can possible. The motion between these two elements, it can be expressed by two independent coordinate, theta or s. They are not related to each other. They are interdependent. So we can say the degree of freedom of rolling or cylindric pair is how much? It's 2, because having two independent motion, one this translation and one is the rotation. So this is possessing 2 degree of freedom. A screw pair or helical pair, you can see this screw pair allow the rotation as well as a translation. When the screw rotates, so it's possessing a rotation as well as a translation. The screw pair But still the screw pair having but rotation and the translation, but one thing is there. So their movement are not related to each other. These are the dependent when the screw rotate, and then the translation motion translation we get between two pair. So screw pair has 1 degree of freedom because the relative motion between 1 and 2 are expressed by single coordinate by either theta or s. Okay, hope you are understood this concept. So simple, you can say when it rotate 360 degree, the screw, it is moved by one lead of the screw. So when you rotate, so it's a move upward or downward. Okay, so we can say it's a rotate and you get this translation, but it is a dependent, it is not independent motion. Okay, that's why we have here 1 degree of freedom. Spheric pair. In the spheric pair, you can say this in this diagram, this is the ball socket joint, and here is forming a spheric pair, and the rotation of element 2 relative, you can see this element overall, this part you can see this one, this two element, this one, and up to this is it is okay, it is deep inside. Okay, so you can see the motion of two, this two relative to one can be resolved in three component, and therefore the complete description of motion require three independent coordinates. Two, you can see two is alpha, and one is the alpha and another is the beta at this position when it is having. So you can see it is represented by two angle alpha and beta, and one is the rotation about their own axis. So three independent coordinate is required to describe the motion of this element 2. So we can say this pair having 3 degree of freedom. So next is according to the nature of the contact. So we have lower pair and higher pair. So in the lower pair, a pair is said to be a lower pair when the two element of pair having the surface or area contact. You can see here that this element 2 is fitted here. Okay, so this, you can see that there is surface contact. So if anywhere, if you found such kind of arrangement, or we have studied all like turning pair, the turning or revolute pair, spheric pair, screw pair, all are come under the lower pair because these pair having either area contact or surface contact. So you can say, for example, nut turning and on the on a screw and shaft rotating bearing universal joint, all are the lower pair. Higher pair, and the pair is said to be higher pair if the connection or between two element of pair is like point or line contact. So such pair is called the higher pair. With the example, you can see cam, ball bearing, cam followers, gears are example. Gear is a typical example of the line contact. Okay, there you can see the point pointed between this follower and this cam. And next is category under the mechanical constraint, and first one is the closed pair. When two element of pair are held together mechanically held together, you can see this diagram, the a closed pair. Under the closed pair, you can see this cam are here. When it is a move, then follower is reciprocate. So this pair are mechanically are held together. There we not need to be providing any spring or some other mean to be making the contact between two element of pair. So this is called the closed pair. Unclosed pair, you can see here the pair 1 and to keep pair, suppose this 1 and 2. Okay, so pair 1 2, this is also example of cam and follower. Here you can see they are held together. To keeping the held together these two pair, there is no need of any external mean. Okay, So they are in contact due to its gravity or some external, by providing some spring actions. So this is called the closed pair. So thank you so much, all of you.